Number 8, a force F is applied in horizontal to a 10-kilogram block. The block moves at a constant speed, that's important, of 2 meters per second across a horizontal surface. The coefficient of kinetic friction between the block and the surface is 0.5. The work done by the force in 1.5 minutes is, all right, so we know power equals work per change of time, and we can solve for work equals power times change of time. Well, we do have the time, but we need to find power. Well, we do know that power is also equal to force times velocity parallel. We do have a force, no, we do have a velocity, but we don't have a force. But what we do know is that we have an object with an applied force going one direction, and we have a frictional force going in the opposite direction, and acceleration equals 0. So if we sum up the forces in the direction of its movement, no acceleration, that equals 0. We have force applied minus force of friction equals 0. Force applied equals force of friction, which equals mu k mg. Mu k, they gave us 0.5. The mass is 10. And g is 10, so half of 100 is 50 newtons, right? We can plug in 50 newtons times a velocity of 2, and we're getting a power equal to 100 watts. Plugging in the power of 100 times the time in seconds of 90, we're going to get work of 9,000 joules. An alternate way of doing this, and perhaps an easier way, all right, so this alternate way, let's see if we can figure out how to erase this. Okay, that's erased. We would have work. So work is equal to force times displacement parallel. Well, we have the force. No, we don't have the force. All right, so an alternate approach to this. We could say, if we're looking for work, we could say work is equal to force times displacement parallel. Well, we did figure out the force. We said that was 50 newtons, right? So if we can come up with the distance and we have time, so the equation that relates distance and time is the second kinematic equation, or x equals x naught plus v naught t plus 1/2 at squared. We already said that the acceleration was 0. So we can get rid of this term. We're starting at a position of 0, so x is going to be its initial velocity, which is 2 times a time of 90 seconds. So we're getting a displacement of 180 meters. We can plug 180 meters in for its displacement, and we're going to get work is equal to 9,000 joules again.